Alrighty people, we're just going to go through some of these questions here, make sure you know what you're doing, and then I have a little short lesson for you to keep you busy on Thursday. Balancing chemical reactions, just a little tip here, if ever you see something like an element by itself, save it to the end. It's probably a good idea because it's a little bit easier to balance at the very end, and don't be afraid to use fractions. Also, if you need some kind of method of keeping track, I like to kind of make a little accounting sheet underneath the reaction there. So for carbon, for example, I have 3 on the left, and then hydrogen I have 8, and oxygen I have 2. On the right, I have 1 carbon and 2 oxygens and 2 hydrogens and 3 oxygens. And then start adding coefficients and change those numbers as you go. So for example, I should put a 3 here to balance out the carbons, but that changes the number of oxygens I have as well. So 3 times 2 is 6, 6 and 1 makes 7. So now I have 7 oxygens. Moving down the list, I see my hydrogens are out of whack, so I'm going to put a 4 here, and that takes care of the hydrogens being balanced. Now I have 8 there, but that also changes my oxygens. This is why we leave oxygen till the end. So I have 6 plus 4 is 10. There you go there. And so then what I have to do is put a 5 here, and then that changes this to 10, and now everything is balanced, 3, 8, and 10. That's how you balance those. We typically don't write ones, but just imagine that they're there. It's going to help us with our ratios. So the question is, if you had 5.5 moles of oxygen, how much water would you produce? Well, 5.5 moles of O2, that's what we're starting with, and we're just going to multiply by the ratio of water to oxygen, and you get that from the balance of reaction. It looks like this. Taken directly from the balance equation, there's 4 waters for every 5 O2s, and you can cross out units if you want, which is going to give me the answer in moles of H2O, which is what I want. And there's your answer there. Okay, let's look at the next one here. And look at number 3. Here's the balance equation. You can also balance it using fractions as well, but this is the easiest way with whole numbers. Okay, and I'm trying to figure out how much iron I need given the amount of Al2O3 I have. And again, the numbers come directly from the equation. It's a 9 to 4 ratio I see. So I just multiply. Again, just always make your units cancel out, so you're left with the one you want on top. Okay, let's look at one more. Okay, number 5, there's the balanced equation, and here is the calculation you're going to do. Again, I'm trying to figure out how much water is produced, so that goes on top. I have ammonium nitrate, so that goes on the bottom because I want to get rid of it unit-wise. It's a 2 to 1 ratio. Cancel out units. I'm left with moles of water, and the answer is quite simply 0.0050 moles of water. And you're done. Okay, that's the answer to the homework, and well, of course, there's another 2 questions or whatever, number 7 and 9 on the back side. You can get those on your own. The next video then is going to be the lesson, which is going to be using those mole ratios to do some calculations. So look forward to that. Here comes the next video.